Okay, so let's look into this first example where it's just looking to expand the binomial, kind of using what we did in the warm-up, just have you done, and then also using binomial expansion with Pascal's triangle. So let's go back and look at this, because this one's a little bit different than just simply x plus y. Now we have something that is dealing with 2x minus y. Now, when we're just multiplying something out, that's really not going to be too much of a difference to us. But when we're using the binomial expansion in Pascal's triangle, that is going to be something important that we're going to want to discuss. So that's why I want to compare these two methods to make sure we get the same answer. Now, before I kind of do this, basically what I want to do is figure out what 2x minus y squared is going to be. So before I get any farther, I want to figure out, let's figure out what 2x, let's do it a little smaller. Let's figure out, let's do it over here. 2x minus y times 2x minus y. Again, that's going to be 2x minus y squared, right? So let's just kind of work this out here. This is going to be 4x squared. This is going to be a negative 2xy minus 2xy plus y squared. So I'm just doing the distributive property just like I've done before, but I'm trying to speed it up here a little bit so I'm not taking too much time on something that we've kind of already covered. Now I just simplify everything up here, and I get 4x squared minus negative 4xy plus y squared. Now again, that's important because I can rewrite this as 2xy minus y squared times 2x minus y squared, right? So this is going to be equal to the 4. So what that means is I can multiply this times itself to give me my binomial expansion. Now again, I could use that using distributive property, but I really do not like using distributive property with trinomials. There's nothing wrong with it, and if you can do it really quickly, then go ahead and do it. I just prefer to have everything organized by using the box method, just because for me, I make mistakes like I did in that warm-up. I'll just quickly kind of try to do things too fast, and I'll get things like misorganized. So I like using the box method, even though I did make the mistake, but just to kind of slow things down and really just keep things organized. All right, so let's go and take a look at this. Again, the box method is you're just multiplying the 2x minus y expanded is these two expansions. And again, remember multiplying is just really like length times width. So the product is really going to be your area of a rectangle, and then we can just add them all up to find the general area. So 4x squared times 4x squared is 16x to the fourth. 4x squared times negative 4xy is going to be a negative 16x cubed y. 4x squared times y squared is a 4x squared y squared. Here we're going to have a negative 16x cubed y. And again, you can always check the diagonals, make sure that they are similar terms. Negative 4xy, so that's going to be a positive 16x squared y squared. That looks good. And then negative 4xy times y squared is going to be a negative 4x y cubed. Okay. 4x squared times y squared is going to be a 4x squared y squared, which matches with that. Here, y squared times negative 4y, sorry about that, is going to be a negative 4x y cubed. And then we have y squared times y squared, which is y to the fourth. Again, make sure our terms look. Okay, so our terms are looking pretty good. Now we can just kind of write this out and combine our like terms on the diagonal. So we end up with a 16x to the fourth minus 32x cubed y plus 24x squared y squared minus 8xy cubed plus y to the fourth. Now you might be looking at this and saying, all right, that's not the coefficients that we looked at over here, right? If I'm raising something to the fourth power, I had 1, 4, 6, 4, 1, and that's what showed up in our warm-up. So like, what's going on? Why is that not, why are those not connecting? And again, the reason are these are the scalar multiples. Okay, so when you're doing binomial expansion, there's a couple things that I really prefer to like to do. The first thing is I want to rewrite this as an addition problem. And I want to use, and I'm going to, I'll just rewrite it as an addition problem. I don't know what else I was going to say. So if I rewrite this as an addition problem, subtraction can be rewritten as a plus, and now I'm going to put the y, the negative y, in parentheses. Okay, so Actually, I'll put both these terms in parentheses. And the reason why I'm putting them both in my parentheses is now you can think about this as 2x, and this is negative y. Remember, these are terms because some of the things that I see students make mistakes on, they'll only raise the x to the power. They won't raise the 2. Or they'll only raise the y, not the negative y, because again, this is a negative y. Okay, so it's very important to kind of think about it in that way. Now, when we're doing our binomial expansion, what we discussed is, we can kind of rather quickly write out our binomial expansion as, the first term raised to the power of the binomial, and the second term raised to the 0 power. And then we just continue in descending powers for the first term and ascending powers for the second term. Let's forget about the scalar multiples here for a second, and let's just do those terms. So I'm going to write this, just draw a nice little line here so I don't get them mixed up. All right, so the first term is going to be 2x raised to the 4th power. Right? So I can take my first term raised to the 4th power. And again, it's not x to the 4th, it's 2x to the 4th. And then that's going to be a negative y to the 0. Now again, I'm only doing this just so you can kind of see the patterns. Once we get into further examples, you're not going to write the negative y to the 0 because we just know it equals 1. Now I'm going to leave a little bit of space, which we'll talk about later. And then let's do the next term. So the next term is 2x cubed times negative y to the first plus 2x squared. And again, you can just kind of follow this pattern. Negative y squared plus 2x to the first power times negative y to the third, and then plus 2x to the 0 times negative 4, or negative y, to the 4th. Okay, so you can see here, basically what we did is we just took our terms, but again, it's very important to make sure that the group 2x and negative y, you group those as your terms, and we just followed the pattern. Okay, and again, our end goal is going to see if we can get to this. Now, the other thing that we didn't talk about is going back and writing in these coefficients, this 1, 4, 6, 4, 1. Those are still there. Those will still affect the problem. But again, they're scalar multiples, so I'm going to add them in now after I've kind of written everything in. And they're a multiple, they're a scalar, so they're going to be multiplied times each of these terms. And I'm going to use a different color so we can see how they differentiate from our other terms. Now, it's also important to notice that there's 1, 2, 3, 4, 5 of these. And when we expanded this binomial, we had 1, 2, 3, 4, 5 terms. Obviously, if you don't have the same amount of terms as your coefficient should be, there's a mistake. Either you're not using the right row in Pascal's triangle, or you made a mistake in your expansion. All right, so now let's go ahead and simplify this, because basically this is the binomial expansion. Now we just want to kind of simplify it and make sure that it equals the same as our the other example. So we have 1. Now 2x to the 4th is 2x times 2x times 2x, right? So 2 to the 4th is going to be 16. So that's going to be 16x to the 4th. And then obviously negative y to the 0 power is just 1, so I'm not going to worry about it. Let's get to the next one here. So here I have 2x cubed, so that's going to be 8x cubed. And then 8x cubed times 4 is going to be 32x cubed. 32x cubed, and then times the negative y is now a negative 32x cubed y, right? Because you're multiplying a negative times the positive 32, so it's now a negative. Here I have 2x squared, which is 4x squared. 4x squared times 6 is going to be 24x squared. Now, so that's going to be a positive 24x squared. I don't need to worry about it being negative because here I have negative y squared. Well, negative y times negative y is basically just y squared, so that doesn't change the sign. So notice when I have my negative term is raised to an odd power, that changes the sign. When it's raised to an even power, the sign remains the same. Interesting. And that's obviously as long as 2x is positive. Here I have 2x times 4, which is going to be 8x. But then I have negative y cubed, which is going to be negative y. So it's really a negative 1 times y cubed. So negative 1 times 8x is going to be a negative 8x y cubed. And then here that becomes 1, that's 1. Negative y cubed is going to be, or to the 4th is just y to the 4th. All All right, so let's go ahead and make sure that these are the exact same answers. And I probably could have showed some more steps, you see. But you can see here that everything going works out, and we're good to go. So you can see that obviously with a little bit more practice, and obviously I showed a little bit more work than you would probably need to be required, but I wanted to kind of show some steps. And I could have showed some more steps with my arithmetic adding and stuff like that down here. But hopefully you can see, at least in this process, that binomial expansion can help you out. It can make things a lot quicker than having to multiply everything out and make some error, in adding terms or multiplying, exponents and such stuff like that. As long as you can understand as long as you have the binomial expansion kind of rules as far as the powers and as well as Pascal's triangle, and with a little practice, you can make this kind of quickly. So now we'll see here that let's go ahead and work on some practice on this so we can kind of speed it up, and that will be in example number 2.